one?
Maybe.
How confident are you?
5 out of 10.
5 out of 10. What's your answer?
I got 3x over y squared.
All right. Well, you're better than you thought. 3x over y squared is correct. Okay, so you got that. You're correct. All right. Second one. Hey, think you got it?
Not really.
Did you get an answer?
Yes.
And how confident are you?
3 out of 10.
3 out of 10. Okay, let's hear it.
72x to the 13th, y to the negative 13th.
Okay, you are correct that you do not know it. Okay, that is incorrect. All right, let's see. Brandon, how about you?
Nah, I don't remember how to do that one.
So you're just passing.
Yeah.
All right, let's go. Anna.
I got a negative 8x to the 13th over 9y to the 13th.
You are correct. Okay, that is the answer. So these are the two. Now, obviously, I haven't taught it yet. And if you don't remember, that's okay. We'll go over it. But you get 3x over y squared and negative 8x to the 13th over 9y to the 13th. Okay, so when we're done. One thing when I was looking at your homework, I wanted to just cover it real quick before I go into the next lesson. And I think the first problem was, I wouldn't know, but Matthew didn't write it down. X cubed plus 125. All right, when you have a difference of sum of cubes, you follow that pattern. You got a to the third plus b to the third will factor into a plus b, a squared minus ab plus b squared. Take on that form. Remember we talked about that, or I talked about that soap. Same first sign if they're both positive, and then always is opposite, and then always positive. Okay, for that. But when you're doing this one, this is going to be x to the third, and you can think of this as 5 cubed. So it's going to be x plus 5, and then it's going to be x squared minus 5x plus 25. Well, this trinomial, that looks like something that can factor. Okay, it's a trinomial. I've been telling you, always try to factor again. Well, if you've done this correctly, that will not factor. Okay, so you really don't need to spend time checking it. Okay, as long as when you're dealing with a sum or difference of cubes, if you've done that correctly, you can't come up with anything multiplies to 25 and adds a negative 5. You can try all you want, but it's so you don't, I guess, spend time worrying about it. Just move on. It should be prime every time. Okay, so I don't think I mentioned that yesterday. I want to say that today. I'll look these over. Like I said, I'm going to grade a few of them, and then we'll kind of see where you're doing. I need to do that kind of beginning of the year, just kind of get a handle on what you know and maybe what you need a little bit of extra help on. We're going into exponents. There's 9 exponent rules. We're going to go through those and basically combine them all to problems like you just did. We're going to start very simple. And hopefully, like when you see this, you'll like, oh, yeah, I know that, or yeah, I remember that. All I needed was a reminder. But we'll go over these and then basically how to simplify exponents. Review a little bit Monday, and then Tuesday on factoring and exponents, we're going to have a 40-point quiz. Okay. So I like to jump in here quick with an assessment and kind of move fast. I got to be honest with you, every year I get a few kids that probably this isn't the best spot for them. Maybe a regular pre-calc course is a little bit better, moves a little bit slower, not as in-depth. And so we got to find out kind of early on if anybody fits in that mold to make sure that they're in the right spot. All right, anything to the 0 power is 1. You know that. You've talked about it before. And what I'll do is I'll give you the rule, and I'll give you just a couple quick base examples. So 4x to the 0, now I said everything equals 1. Well, the x is the only thing to the 0 power, so that becomes a 1. The 4 is not affected, so that's why that one's a 4. And if you have a quantity to the 0 power, then that will basically all become a 1. So and there's the one thing about exponents is there's when you get into more complicated problems, there's more than one way to solve them that are correct. It just depends on how you look at it and how you want to start it. Negative exponents. You're not allowed to have an answer with a negative exponent. Okay, from here on out. Okay, and that kind of was brought up last year a little bit. Whoops, that's not what I wanted. But from here on out, make sure no answers have a negative exponent. So x to the negative third, that's just 1 over x cubed. If you have a constant, this is probably one of the bigger areas where I see mistakes. When you get like 2 to the negative fourth, there's just a lot of people just want to put negative 16. You have to treat that as 1 over 2 to the fourth. That becomes 1 over 16. If the negative exponent's in the denominator, then it moves to the numerator. And basically, you've been taught, wherever the negative exponent is, it's going to move to the other side of the fraction bar. If it's the top, it's going to the bottom. If it's the bottom, it's going to go to the top. So negative 2 over y to the negative third, you do not mess with negative coefficients or negative constants. So that becomes just negative 2y cubed. 1 over 3 to the negative second becomes 9, because that's 3 squared. Okay, for that. All right, so those are the first three. Basically dealing with 0 and negative exponents. All right, it's going to be helpful to be able to just do a few of these without your calculator. And just without this, I want you to simplify this. Now, when I say without your calculator, if you got something like 5 to the 6th power, I don't expect you to know what that is. You can clearly, go 5 to the 6th power is fine, but I don't want you to type that in as is. So 6 to the negative third is 1 over 6 cubed. If you don't know 1/6 cubed in your head, that's not huge. Just do 6 to the 3rd power. You can use your calculator for computation. So this should be 1 over 216. All right, see what you get for B. No calculator. Think it through. Brooke, what do you think?
1 over 4.
Ooh, I'm going to say negative 1 over 4. Okay, I'm going to say negative 1 over 4. The negative is not, if it was in parentheses, okay, now that negative has to travel with the 2. Since it's not in parentheses, the 2, you would think of this as 1 over 2 squared. The 2 would move down below the square. Theoretically, that negative doesn't move. It stays right where it's at. And so 2 squared is 4. You're going to get negative 1/4. Okay, if it was in parentheses, then that would be 1 over negative 2 to the square, which would be positive 1/4 for that. All right, take a look at C and D if you would. Bless you. So what do you think? Now I do have parentheses around there. Parentheses negative 3 to the negative 4th, and then we got negative 7 to the 0. Now if you use your calculator for what 3 to the 4th is, that's fine. All right, Andrew, this one, what do you think for C?
I got 1 over 81.
1 over 81 would be correct. Think of that as 1 over negative 3 to the positive 4th power. And then that's going to be 1 over positive 81. Okay, that would be correct. All right, how about D? Lizzie, what do you think for D?
1.
Negative 1. The negative is not to the power. The only thing is the power is a 7. That negative is not affected. It would be positive 1 if they had parentheses around the negative 7 like that. Okay, so that negative does not get affected by that. So be able to do a lot of these without your calculator, at least have that understanding. Okay. All right, getting into some of the other rules. Multiplying. Remember when you have a to the m times a to the n is a to the m plus n. You're going to add those two together. And now x to the fifth times x squared. 5 plus 2 is 7. Now everything that, all these rules kind of keep adding one on the other. You still have to use rules 1 through 3 with this one. What I mean by that is if you have x to the negative fifth times x to the seventh, doesn't matter if they're negative or positive, you're going to add them together. So negative 5 plus 7 is x squared. If I get x to the negative eighth times x to the fourth, that's x to the negative fourth. You got to write that as 1 over x to the fourth. You got to do that. Okay, you still always have to write everything as a positive. A power to a power. Okay, we call that a power to a power. You only have one base. You multiply the powers together. Okay, so y cubed to the fourth power. It's going to end up being y to the 12th. If you have y cubed to the negative fourth power, that's going to be y to the negative 12, which becomes 1 over y squared. Or not y squared, y to the 12th. Okay, so throw in negatives as well, nothing will change. And then if you have more than one term to the power, then the power has to be applied to everything in the parentheses. So ab to the m is a to the m, b to the m, and then a constant. The constants also get that power. Another mistake I see a good bit is you want to say that's 3 times 3, which is 9. Remember, it's 3 to the third power. Okay, so 3x to the third power is going to be 27x cubed. Now this is where I'll see a lot of mistakes here. If there's a negative power, it still has to be the same case. So this will now become 5 to the negative second power over x to the negative eighth power. So 5x to the fourth to the negative second. And now you have to make that 1 over 5 squared, x to the eighth, and you get 1 over 25 x to the eighth. Numbers to negative powers tend to be what's missed the most. Okay, for that. Jordan, is that a hand?
Oh no, I just didn't.
Okay. All right, now let's take a look here. A to the m over a to the n. Subtract exponents. Okay, it's going to be a to the m minus n. X to the eighth over x cubed. X to the fifth. Now, like I said, you're going to have different options. So x to the 6 over x to the negative second. Somebody might say, well, I want to change that x to the negative second to a positive one. Okay, you can do that. That makes it x to the 6 times x squared. Now you're going to add them. You could also just go x to the 6 over x to the negative second. You could subtract 6 minus negative 2. 6 minus negative 2 gives me x to the 8th. So there's going to be different options to get to the same answer. And one necessarily isn't better than the other. In some cases it might be quicker, but as long as you end up the same. All right, a over b to the m power. You got a quotient to a power. That power has to go to both the numerator and the denominator. So 2 over y to the third. That's going to equal, when we're done, 2 to the third power, which is 8. Anytime, any constant to a power, go ahead and take write that out as a whole number. And now that's going to be y cubed, unless it's like really, really big. All right, and now the last rule that we have here, a over b, a quotient to a negative power, can simplify to b over a to the n power. Okay, you just flip the two, the numerator and denominator, and you change the power. Now, you don't have to go through these steps, but here's what's going on. A over b to the negative n is the same as a to the negative n over b to the negative n. Well, since I got a negative power, I can make it a positive power by moving it to the other side of the fraction bar. So now it's b over b to the n over a to the n. Since they're both to the n power, okay, I can flip that or write it as to the n power. You don't have to go through all those steps. That's really what's going on. You just flip, change it. X over 4 to the negative third will become 4 over x to the third, which will simplify to 64 over x cubed. Okay, so just be careful of that. Now, those are all just real quick, simple examples to demonstrate the rule. Let's kind of throw some things together here and do a few here. All right, constants to a power. We're going to use our rules, and then in the end, we're going to multiply anything we can or take any power we can. So go ahead, you got 2 to the fifth times 3 to the negative second over 2 cubed times 3 to the negative third. The rules apply whether the base is a constant or it's a variable. So this would be no different than x to the fifth over x to the third. You subtract exponents. You're going to make this 2 to the second power because you're going to do 5 minus 3 times 3 to the power. You're going to take negative 2 minus negative 3, which gives us 1. Now this we can figure out. You got 2 squared is 4. 4 times 3 is 12. So you're going to end up with 12 as your final answer. I want you to be able to work with the constants to the power. Okay, so final answer would be 12. All right, copy down number 2. Now number 2, there's really no work. You just have to rewrite it in the correct form. Just go ahead, copy that down, and rewrite that. All right, Logan, what do we have to do to that?
Negative 5x squared over y to the third.
Yeah, the only thing you got to do is move that y down below. And the one thing I don't want you to do is don't move that 5 because that's a negative constant, negative coefficient. That doesn't change. So that's all you got to do for that one. All right, copy down that third one. All right, one thing you just got to be careful here is you still got to follow order of operations. You cannot multiply like 4 times 3. You cannot do anything until we get this, take care of this power on the outside. So this is going to be 4x, and then that's 3 squared, which is 9, and now that's x to the negative 4th. So you got to take care of that piece first before you go any further. All right, once you have that taken care of, now I just can follow my rules. This is 4 times 9, which is 36. This is 2 terms multiplied together. It means you add their exponents. It'd be 1 plus negative 4, which is negative 3. And we would end up with 36 over x cubed. Once you're done with that, there's nothing else. right, now number 4, same idea. You're going to have to take care of that exponent in the denominator before you can do any simplifying. So I got 15 x cubed y to the 4th over 5 squared 25 x to the 4th y squared. Reduce fractions, and I'll do this first part for you. 15 over 25, 5 will go into both and make that 3/5. All right, like I said, some people look at this different way. What do you think then I'll get for my final exponents at this point? Okay, Matthew.
Y squared, 3y squared over 5x.
3y squared over 5x. All right, how'd you do it? You're right.
I moved the y to the top, which makes it negative, and just leave me with y squared.
Okay,
And then I moved the x to the bottom and negative, and that just leaves me with x.
so you did that. Okay, so like I said, people will see it different ways. He said, all right, I'm going to move that up. It makes it negative. That's 4 plus -2. You can just take 4 minus 2, which is 2 right here, and you're done. You can take 3 minus 4, which is -1, but the -1 has to go down below. And I'm sure most of you are also saying, well, I can just do 4 minus 3. Absolutely, I don't care. Just make sure you get that right term. So a lot of you know, like if they're both positive, you're going to do 7 minus 3, and you're just getting 1 over x to the 4th. That's absolutely fine. Okay. All right, let's take a look at a couple more. These last two, a little more, I don't know, depth maybe. Copy that down, but I'd wait a second before you start. As I said, more than one way to do this. Here's what I feel would be a little bit easier to do this. When you got a negative power on the outside of parentheses, I would go ahead and move that to the denominator. So this first piece will not change. I'm going to make it 3x y to the -2nd to the 2nd power. And I'm going to move that whole thing down below. And when you do that, you just change that exponent on the outside. If you can apply that -3 to all those, but then that 4, that's where I see the most mistakes. People want to make it -64. It's not. It's going to be like 1 over 64. Now you're less likely to make a mistake. 3 squared is 9. X to the 2nd power is x squared. Y to the -4. Over 4 cubed is 64. X cubed. Y cubed to the 3rd power is y to the 9th. You cannot change the 9 and the 64. They don't have anything in common. So I just want you to think what's going to be our final. Where's the x going to be? Where's the y going to be? All right. Katie, when you got an answer, let me know.
I think I have it.
You think you have it. All right. What do you got?
I have 9 over 64 x y to the 13th.
X, y to the 13th. All right. So x squared. Okay, that would be -1. It'd move down below. -4 minus 9 is -13. It would move down below. Some people will say, I'm going to move that down below and then add them. That's absolutely fine. I don't care. As long as you get 9 over 64 x, y to the 13th. Okay, good. And let's take a look at one more here. And again, this one, I would say, has multiple ways that you can attack it. What I would do is, since you have a negative exponent on the outside, I would use that very last rule where you make that a positive. When you do that, you will flip the numerator and denominator, but when you flip that, everything stays the same. You don't change any of the inside exponents. So it'll be x to the negative 1, y to the 4th, z to the negative 2nd over 3x squared, y to the negative 3rd. Okay. You can't do both. You can't change the outside exponent, the sign of it, and then change all the inside. You just straight flip it. Okay, and everything will stay exactly as they look. Now I apply everything to the third power. I get x to the negative 3rd, y to the 12th, z to the negative 6 over, that's going to be 27, x to the 6th, y to the negative 9. All right, take a look, simplify it, and Carter, you'll give us the answer to the best of your ability. Got it?
Yeah.
All right, what do you got?
I got y to the 21st over 27 x to the 9th z to the 6th.
All right, let's see here. Y to the 21st is going to be 12 minus negative 9. Agree. Z to the negative 6 moves down below. X to the 9th down below. Good. You could have simplified this before you did the negative exponent. It doesn't matter. And what I mean by that is people might say, all right, well, what's this? 2 minus negative 1? That's x cubed. You could have done that. Negative 3 minus 4 is negative 7. And then z to the negative 2nd, you could have moved that up. You could have done that to the negative 3rd power. Thing you got to watch here is that's 3 to the negative 3rd, x to the negative 9th, y to the 21st, z to the negative 6. And then you would still have to move that down below as 27. The y would stay. But you still get the same thing. Doesn't matter. Okay, it just depends on how you look at it. I like to take away the negative on the outside because a lot of people continue to miss that 3 to the negative 3rd. All right, I just want to put this down in words. You don't necessarily need to copy it down as long as you know it. To be simplified. This is basically as if we were doing this on all the problems. We talked about it, but here are what you have to satisfy. Each base appears only once. You cannot have an x in the numerator and denominator. You cannot say an answer is 3x squared over 7x because it can be simplified. Okay, each variable appears only once. No negative or zero exponents. Everything has to be positive. You can never have a zero exponent. No power is raised to a power. So you cannot give me an answer of 3x squared all to the 5th power because that can be simplified. And then fractions are reduced. Okay, so those are kind of be the key. Base appears only once. No negative or zero exponents. No power is raised to a power, and all fractions are reduced. And let's see here. All right, we'll give you a little bit of time here. Page 27 and 28. The homework is going to be 5 and 6, 15 through 85, every other odd. I think it ends on 85. I can't remember. If it ends on 83, then stop at 83. Okay, so hopefully it ends on 85. I want you from here on out to check all the odd answers in the back of the book from today till May 28th or whatever that day is. That is okay. You're verifying whether you're doing them correct. Okay, you are verifying them. There will be a quiz Tuesday, 40-point summative over factoring and exponents. Essentially P2 and P4 at the beginning of the book. Okay, for those. We'll review a little bit Monday, quiz on Tuesday. Now at this time here, you got plenty of time. This is where I'd expect you to get started in class. Get as much done as you can. I would check them as you go. Do 2 or 3, check them. Make sure you're doing them right. If you're not, then you can ask me. I've told you third period I'm in the academic lab, right? Eighth period's planning. Okay, fifth period's lunch. You guys need help?